Welcome to Homework Lib.
Hi, so over here we're going to have a 5,000 kilogram car that is going to be moving at 10 meters per second. We're told that after the driver steps the brakes, the car is going to continue to move for a distance equal to 1.2 meters. So with this, we want to know what is going to be the force of friction that the road is going to exert on the car. So in order to solve this problem, we can do several approaches. So one of the possible approaches is to use the work energy theorem, which is going to tell us that the change of kinetic energy is going to be equal to the work done by the force. So in this case, the work that is going to be done by the force is going to be equal to force times distance. We're going to assume that the friction is going to stay constant. And the change of kinetic energy is going from an initial velocity of 10 meters per second to a final velocity equal to 0 meters per second. So the change of kinetic energy is going to be the final minus initial, which is going to be 1/2 of mass final velocity squared minus 1/2 of mass initial velocity squared. In this case, the final velocity is going to be equal to 0, and we're going to end up with minus 1/2 of the mass, 5,000 kilograms, times the initial velocity squared, 10 meters per second, squared. Remember that this is going to be the change of kinetic energy. So the change of kinetic energy is going to be equal to 10 squared times 5,000. We simply need to add up the zeros, and we're going to divide it by 2. So we're going to end up with 250,000 joules with a negative sign. And this needs to be equal to force times distance. In this case, the force corresponds to the net force of friction times the distance, which is 1.2 meters. So the change of kinetic energy is going to be equal to minus 250,000 joules divided by 1.2 meters, which would be a force equal to minus 208,333.333 periodic newtons. And this is going to be the net force. Sorry, over here I cannot kind of overdid the steps. So over this is going to correspond to the force of friction that is acting on our system. So this is going to be the final answer. Notice that this is going to be negative, so the magnitude of the force is going to be this number without the negative sign, but since we know that in the movement of the car, the force of friction, if this guy is moving with a certain velocity, the force of friction is going to act on the opposite direction of the movement. And with that, it would be all. Thank you very much and have a good one.